Ginger Tapia. I'm the chair for the EDIJ committee, and we are pleased to present today Jean Hewitt. She is associate from Borough Hapold's office and coming live and direct from London this evening. So thank you again for taking time out of your usual business hours to educate us in the US.
Wonderful. Thank you. So good morning or good afternoon. I think just good afternoon for you. Good evening for me. So the agenda, I'm going to talk about sensory design in its broadest sense. So we'll start off looking at sight loss, then look at hearing loss, and then look at sensory difference and neurodiversity. And I'm then going to talk about a new standard in the UK, which is, I think, going down very well here and is being picked up internationally as well. So we know that it's reached Australia and that they're looking at it there and teaching students there. So I hope this will be of interest to you. And then I will finish with some Q&A. I've got a lot of slides, but some of them I'm going to go through rather quickly. They're just kind of images. And I think you can have a look at those afterwards. What I can do is also provide PDF of the slide pack if people would, rather have a slower read later.
Great, I appreciate that.
So in the UK, we talk about inclusive design, and this has got 5 principles to it, which is the first of which is placing people at the heart of the design process, acknowledging that there is human diversity and difference in all of us, and trying to offer buildings and environments that offer people dignity, autonomy, so that anyone can rock up and use facilities and enjoy facilities in the same way, and that they have choice and they're allowed to do things in a spontaneous way. Providing for flexibility in use for different user types and user needs, and generally providing buildings and environments that are convenient and durable for everyone. So within that is the sensory access to the built environment, and we do have hundreds of senses. There are usually 4 or 5 that people most commonly think about, but when I'm talking about the senses, it is everything. And we start with hearing and vision. Really the most important ones, and then look at vestibular and proprioception, how we judge spaces around us, how does our balance work, and also our sense of smell, because that influences how we enjoy the built environment too. And finally, looking at touch, and I'm going to touch upon all of these today. So I'm putting a slide up now around accessibility and inclusion because it's such a broad area. When I started out 25 years ago, we were really predominantly looking at wheelchair access and perhaps people who needed walking aids and physical access, really. And it's so much more these days. But today, what I'm going to be talking about is specifically within the pink bubble. So hearing, sight, cognitive difference, neurodiversity, which is this infinity symbol, and of course, mental health and well-being, which I'm showing with a semicolon symbol, so a life paused but not stopped, which is a symbol that's quite reasonably common here, and I think is growing as a symbol across Europe. I'm not sure if you use that in the States. And the reason I've included that today is really because the way that our senses, we experience information and process through our senses can affect our mental health and well-being. And if the built environment isn't designed appropriately, our mental health and well-being can suffer and can be lower than it could be. So this is really the nux of what I'm talking about today, is how can we do this? What will make a difference to people? So I'll kick off looking at sight loss first. The terms we would use in the UK are blind, partially sighted, or low vision. All of those are equally okay to use. But with sight loss, only 5% of people who are registered blind have no vision at all. 95% of people registered blind have some vision, and that making the most of that vision is really, really important. So they may have sight loss that lose the central detail, or they could have sight loss that uses the peripheral vision, maybe gives them a remaining tunnel vision, or they could have loss in both, and they can have patchy vision and numerous other types of sight loss. So it's really important when we're designing for people to try and consider all the different needs across the spectrum of sight conditions. I'm showing you now a picture of a market stall, which has lots of rich colours of beautiful fruit setting in probably a London market, I imagine. And that's how it would be seen by someone with unimpaired vision. Maybe wearing glasses to correct it, but not beyond that. This is what the same scene might look like if you had a type of sight condition that caused patchy vision. So this particular one is indicating diabetic retinopathy. So it's from diabetes, and you can have patchy vision. In the worst case, you can lose your sight altogether. But this is what it could look like with patchy vision. And then this one with the loss of general acuity, typically a cataract type of condition, so very common, often very fixable as well. And then this one is the most common form of sight loss, macular degeneration. And this one is the tunnel vision. For example, you can experience something like this with Usher syndrome. So depending on the nature of your vision loss will influence what you need from the built environment in order to use it and to engage with things. So for example, with tunnel vision, it's quite difficult to move around because you can only have a small window through which to see, but you might be able to read a newspaper. Whereas with something like macular degeneration, reading becomes very, very difficult, and your peripheral field is usually okay, but obviously you've got lost that very fine acuity where we do our detail reading, which is in the center. I'm sure many of you, have touched upon this before, and good visual contrast will help around 80% of people with sight loss. So this is not a color difference, but a tonal difference between two finishes. And we usually measure that in a light reflectance value. The other things that are important are adjustable lighting, both in the brightness, but also in the color temperature of the lamp. And whether we can switch it on or off as well. And also cutting out, of course, glare and reflection wherever we can. And then good signage, which is contrasting, and the text is large enough. And if it can be embossed and have braille, that's really, really helpful for people with the more severe types of sight loss, so that they can feel the signage. Now, braille is used again in the UK anyway, by around 5% of people with sight loss. So for many, many other people, having embossed lettering and numbers and so on signage, where that signage is within reach, can be really helpful. We also have, of course, touch and tactile information. Much of it is underfoot, so tactile warning surfaces you will see, and this varies across the world in the way that it's done. So I know that Dubai has, for example, and the Middle East has much more in the way of tactile information underfoot than we do in the UK at the moment. And then the matte and low reflecting surfaces are truly important as well. Just to illustrate the point I was making on colour contrast and visual tonal difference, you might think, looking at the top picture, that those chairs contrast from one another, but when you look at the bottom picture, you can see how it can be seen monochromatically for someone who cannot see colours or sees colours differently, which could be colour blindness. It may be nothing to do with a sight loss condition. And what we're trying to do is achieve enough tonal difference so that when you convert a colour picture to a black and white or grayscale, you can still see the differences between adjacent surfaces. And typically what we'd be looking for is contrast between walls and ceilings, walls from floors, doors and columns, so anything that you want to find, like a door, or that you shouldn't walk into, like a column. Things like stair nosing, so the edge detail on stairs to make sure that we can see the edge of the steps and judge them correctly. And then the smaller details such as handrails, handles, and even furniture. We don't want our furniture to blend with the environment it's placed within. And although that may make an environment feel much more spacious, it's actually quite dangerous when we're not paying attention or when we have a sight condition. So there are different ways of measuring visual contrast. So you can, in the crudest way, is basically to take your photograph and change it to black and white and see if there's tonal difference. But there are ways of measuring it as well. And there are various paint manufacturers that have come up with numbering systems. So this one's by Dulux, which shows how you can, it gives you the values for the light reflectance value, and then you're looking at a points difference between two areas. So this is just an example, and it may not be the way that you do it in the US, but I think it's helpful to know about that system. And then what you can do is color match against a swatch of colors to find out, if you're out in the environment, what color you're using or what color's been used, which is harder in a given environment. We also have a chromacon meter, which you can place on any surface, and it will give you that points value. So that's really useful in the architectural field, and certainly I know when I use them in my work, many architects then go on to buy such a device. Safety manifestation and glazing, I'm pretty sure this is going to be in your code anyway. Here we have 2 bands at the moment, so you can see here that they're broadly eye levels for seated and standing approach. But we are currently recommending also that clients consider a lower band as well, right down at the bottom of the glass, which is more for younger children. We've had a number of cases where children, young children particularly, and I'm talking probably under toddler size, probably 3 and under, where they've run into fixed glazing because they haven't been able to see it. So we think that's really important in certain types of buildings at least. And then there's lots more to vision and so on, but I'm going to come on to that a bit more when I talk about the PAS standard around neurodiversity, because there's a lot of overlap between all of these. But the one that is unique, I think, for many people with sight loss and hearing loss as well, is that they may have an assistance animal. Obviously, we've got to provide facilities for them, particularly for toileting, which we tend to call a dog spend or a dog relief area. And this is a picture of one at the Royal National Institute for the Blind. They've put theirs outside. We've also got clients that have them in the basement car park, want areas that they can hose down and so forth. So it really depends what facilities each building has. This one happens to be near a park as well, which is really useful. But the other thing that's come up quite a lot is considering space under desks and in waiting areas and alongside seating in theatres and things like that for a guidance animal. And one of the things that I came across recently was the importance of having a modesty board on a desk. Not for the modesty of the occupier of that desk as such, but actually for the dog. So Labradors in particular, and many Labradors are guide dogs or assistance animals, like to lie against a wall. So if you have open plan desking underneath, it means that they're then creeping under somebody else's desk. So it's just really simple thing like having a modesty panel on a desk is really helpful to try and stop that happening. So touch on hearing loss. This is the biggest number. So just for comparison, in the UK, we have around 9 to 10 million people with hearing loss, but only 2 million with sight loss. And that proportion is probably pretty true across the world, I would think. The numbers are increasing with hearing loss because we have age in society, and with age, automatically, you do get a degree of hearing loss. So, for example, in your 50s, 40% of the population will have hearing loss, which rises to 70% in the over 70s. So it's quite common. I wear hearing aids myself. I didn't when I was younger. So that's just natural hearing loss. The hearing aids are great, but they don't, depending on the amount of hearing loss that you've got, they won't fix everything. And of course, 1 to 2 in every 1,000 babies are also born deaf as well. So we have people who have acquired hearing loss, usually in later years, but we also have younger people being born with hearing loss. And there are different types of hearing loss as well. So when someone says, well, I've got hearing loss, or I'm deaf, or I'm deafened, really without asking further questions, you don't really know exactly what they might want from the built environment or the buildings that you're running. So there's conductive hearing loss, sensory neural hearing loss, or a combination of the two. So a vast difference there. And communication forms could be anything. So a lot of people will gradually learn to lip read, but even a really good lip reader that's trained will only have 60% accuracy to that. So usually you're talking about introducing some form of technology. And these days you can get, sign language over a tablet or a mobile phone. You can get translation services. There are also, of course, the traditional forms of writing something down, palantyping, which is basically a stenographer who's in the room for the session and is typing with a specialist device and bringing up the text on a computer or on an adjacent screen while in a very live situation. And of course, like today, we can have subtitles on any of our virtual meeting calls and presentations as well. So lots of different ways to communicate. But in terms of what helps in buildings, suitable acoustics is top of the list. Sufficient lighting correctly positioned so that people can see to lip read. And to wayfind and everything, and clear signage and information. Not everyone with hearing loss has clear speech or is able to speak, so they might be non-verbal. So the clearer the signage and the information available around a building, the less need to ask and the less likelihood of embarrassment or any awkwardness. But technology is a huge, huge impact for almost everyone with any type of sensory difference. So we call them assistive listening systems. I think historically we called them a hearing enhancement system, but then we realized that actually we weren't enhancing hearing at all. We were actually assisting people to listen better. So over time we've changed that. There are 4 key types. The induction loop, which many of you will be familiar with, is the most common and it is the cheapest. It is a loop system, loop run round within the wall, usually of a room. And everyone can hear and pick up the signal within that loop and a little bit outside of it. And you can get some overspill with this, unfortunately. So what I mean by that is if I'm a hearing aid wearer here or on the floor below or the floor above, I might well be picking up some of that conversation. So confidentiality can be a real issue with an induction loop system unless you start introducing some sort of white noise to stop that. And then a radio system is highly flexible because it's portable, it's non-wired, but you might still have some confidentiality where somebody else could tune in. But the infrared system is the one that you put, for example, in a doctor's surgery where you really don't want, or a bank where you don't want somebody to hear because they won't be able to. And then there's the sound-filled system, much more sophisticated, much more expensive, but really recommended for learning environments such as schools, colleges, universities, theatres, and so on. And what I'm picturing here is the hearing aid. This is a very standard hearing aid that we'd have here. And there is a T switch on the hearing aid. It's tiny, and that stands for telecoil. And when you want to use an induction loop system, what the hearing aid user has to do is switch their hearing aid to the telecoil setting. So that's why it's really, really important that if you have any form of hearing assistive listening system in your buildings, that you put up a sign to say that it's there so that people know, because otherwise they could be carrying on just trying to manage and not realize that that device is there for their benefit. So that's a quick run through assistive listening. There's loads of other assistive technology you can use, particularly for hearing loss. As I mentioned, the tablets, and there's the palantypist. In hotels, there's under pillow or under mattress alerts that vibrate when the fire alarm goes off, so that people know to leave the building. People can wear wristwatches for the same reason. And you can get, obviously, phones with inductive couplers that will amplify voices and sort of type talk. In the UK, we have something called BT Type Talk, which is a kind of operator service where someone will translate on the line into text. But of course, text phones and SMS texting has changed the world for deaf people, and lots of people will use it to translate, to text back and forth rather than having to make a voice call, which is an amazing difference to people. You can also get visual alerts to doorbells, and you can get trembler alerts for if the fire alarm's going off that you can wear on your belt or something to let you know, and as well as the flashing beacons, of course. So sensory difference and neurodiversity, then, what is that? Neurodiversity is an umbrella term. It's talking about the variation in neurocognitive profiles, that's our brain types, across the whole population. So human beings don't come in a one-size-fits-all neurologically similar package any more than they would in any other way. So we're not all the same size, the same height, the same appearance or skin color or hair type. So why would we think our brains would all be the same? Well, of course they're not. There are natural and normal genetic variations. So collectively, under that umbrella, we are all neurodiverse, because neurodiversity is the full spectrum. So some of us will think and process information in slightly different ways. We might learn new things in different ways and communicate differently and navigate our way from A to B even in a different way, and generally have an experience of the world that's slightly nuanced. I hope people can see it, but across this little graph at the top right, I've got a dotted blue line, which is entirely straight. If you had a cognitive profile like that, you are a robot. You do not exist. You cannot be a human being. Human beings are going to be slightly better at one thing than another. So an average neurotypical person, so that is someone who meets the stereotypical for norm, if you like. I hate to use the word norm, but a stereotypical person would have a slightly undulating zigzaggy line like this yellow one. So fairly modest differences between a bit better at sport than you are at art and so forth. This zigzaggy, really deep one, the green, is someone with a neurodivergent profile, which means it's much spikier and they don't fit that majority neurotypical model. And it means that there's going to be probably some areas of brilliance, but also some areas that are more challenging for them. So that's how the terminology works. And it might be slightly different in the US, but that's how we're using it here. And then neurodegenerative is having a progressive condition such as dementia or Parkinson's that has been acquired through age, usually. Whereas the neurodivergent, most of neurodivergent people are actually born with this sensory processing difference. Within the sensory processing differences that might be experienced under the neurodiversity umbrella, there are two extreme ones. One is hypersensitivity, which means that you experience everything much more extreme and to the point where you can have sensory overload. And sensory overload can affect your heart rate, your breathing. It sort of gives you that fight or flight mode, can cause mental distress, can change your behavior. And around 70% of people who are diagnosed with a neurodivergent condition are believed to be hypersensitive. Some of the others, not all, will be hyposensitive, which means they're undersensitive and they will seek out additional sensory stimulation. Now, if I was hyposensitive, I can self-manage as an adult. I would be able to self-manage that. I can wear fidget jewelry. I can have stimming devices like fidget devices. I could wear bright colors and I could have bright things on my phone and my screensaver and so on. So I could wear headphones with music and I could give myself that sensory stimulation. But when it's the other way around and I'm hypersensitive, I don't have a way of filtering out what the built environment is doing to me. So this is the really important area that I'd like to look at now, because a lot of this is in common with sight and hearing loss conditions, in that it changes how you experience through the senses. Now, most people who experience challenges in the built environment like this don't have a formal diagnosis, I have to say. So they'll either be undiagnosed or they will be neurotypical, so meeting the societal norm in many areas to the effect that it's not been picked up. So they'll have spikes in one or two areas. Or they have another condition that unknowingly is affected by elements of building. They don't consider themselves to have that label, if you like, but can still be affected. And examples of this might include, for example, migraine sufferers. So people who get a lot of headaches. Quite often it can be an oversensitivity to lighting or to patterns and visual stimuli or to noise. So it may be that they are more hypersensitive to the environment around them, and that is causing the headaches. And then there are people with vestibular conditions. So a vestibular condition is a balance condition. So my husband's got Meniere's disease, which is about a vestibular condition. And we've worked a lot with the Meniere's Society here in the UK, and who specialise in balance conditions. And I've spoken a lot to groups of people with balance conditions. And I know that many of the visual disturbances that people with sight loss and people with sensory processing differences experience are very similar to people with a balance condition. So it's the same sort of triggers that are upsetting people and making life difficult. So this is the standard that we've come up with in the UK. It's called PAS 6463, which stands for Publicly Available Specification. We called it Designed for the Mind. That's a historic name, but it is about the brain and how the senses work. And we added in neurodiversity in the built environment to make it very clear we're not talking about behavioral differences in psychotherapy or anything like that. We are purely talking about buildings in this standard, and we're talking about neurodiversity in its fullest form. So there will be some people who will benefit from this standard who believe they're neurotypical, but they will still have some benefit. And we had to think all the way through the 2-year period of development that we couldn't conflict with any existing standard, and we couldn't repeat any existing standard, and we shouldn't compromise access and inclusion for anyone. So we had to be very careful, and everything was very tested and went out for public consultation, etc. So who benefits from this? I think anyone could. And we've said that it's not about necessarily people with a label. It is about a broad spectrum of neurological sensory processing differences. And that might be because you have autism or ADHD, or it could be because you've got a sight loss condition, or you've got dementia, or you've got hearing loss. So we've tried to avoid any diagnosis or labels as far as possible. This is the contents list of what's in there. So you can see we follow the usual start from concept, site and building layout, and then work your way through the building, finishing up with kind of escape and evacuation type of situations. And then there's a section at the end that has a little bit more deeper dive into different building types, such as education or shopping and retail, etc. So one of the sections is on site and building layout, and in here we talk about facade design. So, for example, patterns like this can be really disturbing. So we can do a lot with buildings these days. We don't have such traditional building styles now. We can play around with glass and steel and create wonderful shapes and so on. We can also create wonderful patterns or not so wonderful patterns. So a lot of this can become quite overpowering, and I don't know whether some of you are experiencing now looking at that image, but it can cause some sensory movement and visual disturbance. The other thing to consider is orientation, how people approach a building, what it's next to, what the sight lines are from outside the windows and so forth. And then we cover wayfinding a great deal because many people with neurodivergent conditions get lost. And we think some of it might be to do with attentional bias, and the way that the brain accepts one type of sign and then seems to filter out others. But for some people, it can also be about memory. So not necessarily a poor memory, but a different working memory. So retaining lists live in the head can be trickier, like directions and so on. But there's lots more that can be done, I think, in this area. So what really helps people is to have advanced information and preview. So one of the ways of doing this is to be able to view into a building through windows, but it can also be putting information and fly-throughs on websites, things like that. Providing good information before someone goes somewhere can be really helpful. Sometimes the cause of sensory overload is the unexpected. So the more that someone can be forewarned and can see what something is going to be like, the less likely it is that they will experience sensory overload. Use of colour and shape, really important on the signs. Consistency, not too bright and so forth. And also we're finding now, of course, that technology is a huge benefit. And what we must do, of course, is to provide multimodal wayfinding so that people can have a choice of how they choose to find their way around a space or to a building. So what I mean by that is that there shouldn't just be the fixed signs, but perhaps you have some technology such as an app or satellite navigation, or there's even some software packages for people with sight loss where you can find a friend and it says, "Be my eyes," and they can talk you through from your phone exactly what is ahead of you and which way to go. So we have some great technology coming through now on software, particularly for wayfinding and people with sight loss. And then the clarity of the space and the way the signs are positioned, of course, all that helps, but also identifying key facilities. And that means less asking, less wandering around and getting lost, less anxiety. So the key things to obviously identify for most people are going to be the toilets, which you always need on arrival, where you can go for assistance, quiet rooms, which I'll come on to later. And I think sensory mapping can be very key to this. So we're doing quite a lot of work on sensory mapping at the moment with clients, but this is just an early example that went into the PAS standard as a sensory map, which is of the Museum of London. But basically, it's identifying at a glance where the noisy areas are, where the bright areas are, and so forth. And that's, I think, what most people want is to kind of have some warning about where they're going, and they can make choices. So a lot of this PAS guidance is around giving people back some choice and control over how they use buildings. Now, section 8 is on internal layouts, and I think this is very interesting for architects. So we're looking at how you transition from one space to another, and the layout and symmetry of spaces. And the more that you can create a kind of familiarity and clarity to a space, the better it will be. For offices, as a typical kind of building type, just having control over where you have to sit can be really helpful. So, for example, many of the offices that we're looking at now will have a quiet floor and then some collaborative floors, or a quiet zone and some collaborative zones, so that people can choose, is today the day I'm going to have lots of meetings and socially interact with all my colleagues, or have I got to get that really, really complex business report out, in which case I need to go into the focus space, get my head down, not be interrupted, and so on. So giving people choice is really, really important. And what we've found is that since COVID, people need this much, much more. They're so used to having the control at home that in order to entice them back into offices, we need to kind of compete with a home environment where everything is tailored. And the way of doing that is to give them choices of different types of space they can work within. And in that way, many of these people with different sensory challenges can really flourish and do their very best work. And then this chapter wasn't on my sort of radar when we started the 2-year development period. So I was technical author, and I worked with a steering group of experts in the field. And you know, I know some people have a sensitive sense of smell, but I hadn't really thought through about what we could realistically do about that. But of course, you get off-gassing, you know, these volatile organic compounds, the VOCs, and the odours that can come off of those. Some people might smell them just slightly, but for many people it's overwhelming. And even things like the cleaning materials that we use, and the perfumes that we want to add into toilet areas and so forth, for some people they can be quite detrimental. And then switches and controls, of course, under mechanical, electrical as well, which also give us some control back over our individual environments, just whether it's opening a window, switching a fan on, or switching a light off or on, or changing adjusting the light level. Control of air quality, of course, really, really important as well. So not just around removal of chemicals. We did find that using plants can be helpful. I mean, plants are a biophilic feature anyway, which is helpful to everyone, because our innate connection with nature means that when we look at biophilic design and bringing nature inside, we are helping everyone to feel that little bit calmer. But also plants can clean the air, certain plants can. So, for example, bamboo palm can apparently remove formaldehyde odours. But also, of course, facility management teams need to purge clean with cold, fresh air periodically as well, which will help. And then acoustics, I think this is the #1 top of the list for many people. It's important to sight look when you've got sight loss, so that you can still navigate and you're not picking up lots of echo and so on. It's important when you've got hearing loss that you can make the most of the hearing you've got left. And it's very, very important if you're hypersensitive not to have things reverberating around the room and echoing too much. So we looked at acoustic layout and zoning and how you can offer people different options. And we took some criteria from special educational schools here, which are very strict on the acoustic levels. And we added it even further. We went a step further than that. And we had input from, leading acoustic manufacturers, the steering group experts, and Bureau Happold Acoustics as well. So some of the things we looked at was the absorptive materials, carpets, finishes, and so on. Even little things like lids and cupboards and flush on toilets that make more noise. Can we go for the quieter ones? Can we choose quieter kettles or washing machines or dishwashers, low noise appliances? In shared environments, we did look at whether therapeutic recorded sounds might be beneficial to drown out some of that bad noise. Some people can't tolerate that though, so it's very individualized how we do this. So I think consensus and consulting with people in the building is really important. I mean, unwanted noise is a significant issue, even if you've got, average sensitivity through the senses. So I do think there's a lot we can do in this space, and I think we should generally be going much further than we currently are, certainly in the UK anyway. So that's just an example of a snapshot from as a table from the acoustic section. And then lighting was the second top from the list. Daylight, glare and shadows were a nightmare for many people, either causing sensory overload or being confusing for someone with sight loss, or making lip reading difficult or impossible. And then the photophobia and flicker rates. So many people said, oh, we must get rid of the fluorescent lighting, and LED will be so much better because LED does not flicker, and it does. And what we found is there's an incompatibility that can arise between the driver technology and the lamp, which can cause a flicker, which the majority of neurotypical people can't see. And lighting specialists until recently thought humans couldn't see, but it's now become obvious that humans with this hypersensitivity can see the flicker, or their brains know there is the flicker. And that, of course, can cause the headache, sensory overload, and so forth. In essence, the incandescent original lighting is the better one, but of course it's banned here, and I'm pretty sure it's banned where you are as well. So we are going down the LED route for energy saving. We even looked at illumination ratios. So you want lighting that's fairly consistent and even, rather than it jumping from light to dark, because the eyes have to work very hard for that, but also it causes that too much stimulation for people who are too sensitive. One of the bigger things here was the warmer colour tone of the lighting. When you buy lamps, you often see cool white or warm white. So the warmer ones were much more palatable, if you like. They were tolerated much better by people with neurodivergent conditions with a hypersensitivity. And I'm just showing here, and I'm not going to go through this, but this was a technical paper, which is a spin-off from the PAS document, which is looking particularly at healthcare design in the UK and some of the problems that were coming up with LED lighting there. And this image is just showing you what I mean by the colour temperature and the range, and how that is akin to, the circadian rhythm and what we go through with natural daylight. And it's this bluer light that is seen as much more intrusive, and that's why it helps us concentrate and makes us feel more awake. And then surface finishes, colours muted rather than vivid, so not too bright, where possible, and particularly where people are sitting for any length of time. The biophilic patterns were found to be less intrusive. So it's a pattern of leaves and flowers, etc., is much more tolerable than a very stark pattern. And then we looked at things like, some of the moire effect, where you get this kind of, I don't know if this is moving for someone, but that can be quite common. And the next picture shows similar thing. Some of these have been known, these entrance mats, to give people epileptic fits where they are visually hypersensitive, and it almost creates a flicker as they move across it. And here we've got some of the patterns to avoid. Geometric patterns, they can affect how you walk and your depth perception, as well as triggering headaches and visual disturbance. So lots to look at on patterns, and I'm hoping that one day we'll have an algorithm that will help us do at a glance know. And things that you can do if you want a really interesting pattern, but you don't want to cause people difficulties, you either put it like here, somewhere where the bins are, so that people aren't confronted it for any length of time, or if there's a meeting table here in this picture, here, so people will be sitting over here, What we didn't want is in their kind of peripheral vision, main area of vision for them to see it. So we put a plain piece over the top of this pattern, which we felt could be visually disturbing. So there are ways of ameliorating the impact these things can have. And then fixtures and fittings, obviously lots of quiet stuff if possible. How we position it is important, symmetrical, approximation, not too close together. People with dyspraxia can walk into things, misjudge things. So furniture with rounded corners, really, really helpful. And use of natural materials takes you back to the biophilic again, and that familiarity jumping in there. And then this next section, 14.1 was quiet restorative spaces. The main part of this actually came from a colleague of mine, Toa, who was one of my students at UCL, and she did research with over 300 people with autism and what they would need from a quiet room. So we had a really nice piece of fresh research there that went in and really looked at a deeper dive, if you like, at how you should create a quiet room, which is where someone goes to recover. They need to be wheelchair accessible so they can accommodate everyone, but generally small is best. So you typically 1 to 3 people. And there's a nice checklist that Toa came up with as well that are in the annex. So overall then, that PAS standard is not prescriptive, it's not mandatory here. And it's just full of considerations about how you give people choice and variety, because we are neurologically diverse. And this is the BBC in Cardiff, their offices. They wanted this lovely pattern on the glazing manifestation pattern. But it has, of course, got these linear patterns to it, and it is reflecting. It's quite reflective as well. So there were 2 options that the architects came up with, which I thought were great, that they could enjoy that pattern on the outside, but if you're sat in the meeting room all day, have some frosted, opaque manifestation on the inside, or even have a voile curtain that you can pull across. So that's the kind of flexibility that we want to give people, so that they can amend places a little bit for themselves. So my case study is the Royal National Institute of the Blind. This is the building. It's a beautiful building. It was built to look like a church, but it is an office building. And the Royal National Institute of the Blind bought this building in a pretty sorry state of repair and refurbished it. And they have introduced recording studios, sight loss consulting rooms, as well as their offices. It's a small building. This is the footprint. To give you some idea, it is 5 floors, including lower ground. Here, the client was very open-minded. The PAS wasn't published at that time, but they said that they would like to try and follow the principles, which we managed to do. And it really, really wasn't that difficult. And I thought it would have been, because we were trying to combine very deep needs for people with sight loss. They have I think it's 15 or 20% of their staff have sight loss, plus they have people coming into the low vision clinics. So really, it was a very complex building, and the number of combination of uses that it was offering, but clarity and flexibility and the acoustics were absolutely key. And these are just kind of showing you some of the considerations that we went into around getting the acoustics right. They had a flare path, which I'll show you in a moment. There's some very bright colours going on, so we had to work our way through those to try and make it a more calming environment. So I've got a picture here. This is the main reception. This flare path, which is like a guidance path that is tactile, it's got a bump to it, little bumps on it, would normally be in a very contrasting colour, where here we've gone from monochromatic on the floor. And actually, visually impaired people found it was just as good. And many other people said it felt so much calmer that they're going to copy it, I think, across their other offices. So it's a nice clear space. You've got that kind of clarity of sight lines. They have got little pops of colour, but it's not overwhelming and everywhere. And you can see here some stronger manifestation on, they've colour-coded the floors. And this was the yellow floor. Their colours are really, really rich. They're very bright branding colours. But here, we toned it down, and we did lots of testing in situ with visually impaired people and people with neurodivergent conditions to make sure it was right. And then a nice clear meeting room as well. This is their living lab, where they do user consultation in there for some of the equipment. They have a shop over here, and they use this to set up and show people different lights, fittings and so on. The unique elements, well, for those of you that know your light reflectance values, you know you get this sort of tonal contrast if I looked at it in monochrome. We had to have acoustic panels over reception, so we thought, why not try and replicate that? Just so it was a talking point so they could talk to people about it. Nice bright colour coding to the kitchens, just at the back there. Very strong contrast handles from there, and the little cupboards only open a 300 mil wide, so I get what's that? It's about a 12 inches instead of the double width, one big door, which means that when you open the door, it doesn't overhang the worktop, so you're less likely as a visually impaired person for it to hit you in the face. This is their NaviLens code, so if you were walking around with a mobile phone, that would tell you exactly where you are in the building and how many feet away that point was and what it was for and how it was equipped. Nice tactile labels on cupboards and so on. They've got tactile on their handrails, telling them how many steps they are from the bottom and the top. Here's the tactile on the other kitchen units. And they've got other things like marine edge worktops, which are really useful because the water doesn't just roll off. It gets caught at the edges, so no one will get scalded. So lots of nice interventions on this project. And then the lighting, they did lots and lots of trials to come up with what was it that people wanted, both in terms of dimming and the style of the lights, the diffuser cover, and also the color temperature. And we can see here, I thought everyone would go for the warmer, but actually, because a lot of people had sight loss, they actually wanted a slight cooler on average, a bluer light, and that would give them the acuity that they were then lacking. So that was an interesting exercise. And what we ended up doing is on every batch of desks, so there's 4 desks, they would have some switching, and they could control the lux level, the brightness, and the color temperature. And over time, people have just decided where they normally like to sit and what sort of lighting it is. So if you're the person that wants the dark corner, you go to the kind of the same desk at the same, every day, and so on. So they've worked it out really well. And people have come back into the office who thought they never would. So designing for sensory inclusion is an environment that's got clarity. It gives them choice and control back to the users for sure, but it also has a calm place to escape to when it's all too much. So I think I'm coming, this is my final slide now with just a few links in it. So I'm going to stop sharing because I will send this pack round for everyone.
Jean, thank you very much for that presentation. I found the neurodiversity section and thinking about the built environment was enlightening, right, in a different way. I worked in an office that had the striped carpet, and I couldn't look down when I walked because it totally threw off my balance. So understandable. So at this point, we have a few minutes left. I'd like to open up if anyone has any questions. You can either send in the chat or feel free to unmute yourself and ask Jean.
Yeah, I have a question, Jean. First of all, it's a very good presentation, and I think design for mind and neurodiversity and built environment is a very is a requirement not just in UK but universally. Do you think these standards PAS 6463 can be implemented or can be duplicated on universal level as a mandatory part, or just an option for design consideration?
So PAS is an evaluation standard here in the UK, so it means that everyone can try and use it and evaluate it, and at some point it's likely to become a formal standard. The take-up has been very good, and the reach has been further internationally than we had intended, which is great. So I'm not sure at the moment what it will become. It could be a British standard, it could be an international standard, or it may just be a reiteration of the PAS, but with more information for now, while it's still being evaluated. Because of the great take-up on it and the amount of interest it's had, there's discussions are still ongoing about which direction it should take next. But what we're finding is most of the architects are actually doing it voluntarily, and they're really, really interested in doing it, because I think everybody can can consider this and know either they're affected in some way themselves or somebody close to them will be. So it's got a lot of interest and a lot of passion for people to pick this one up, I think.
Yeah, that's fine. Okay, that's nice to know. But thank you for sharing very good information.
I have a question.
Hello.
Hi, this is Barb Afsar, here in California. When did the UK started their ADA process, if you know?
So we were very behind the US. So we had our Disability Discrimination Act came out in 1995. And then the building regulations followed in 2001 to 2003 when we first had to change our buildings.
Right.
From that point. So, and then since then we've got British standards, and then we've galloped along a little bit. Last 5 years or so, we've done a lot more.
Fantastic. Thank you very much. Thank you for the presentation. Wonderful. Thank you.